Hi there, it's Mr. Miller. Welcome to video number 21. Today we have a quick video on vertical angles. So first question is, what are vertical angles? So vertical angles are formed when straight lines cross. So this first example is an example of vertical angles. These lines are straight, and the opposite angles here, the ones I'm shading in, are vertical angles. These other two are vertical angles also. Sometimes they're called kissing angles because it looks like they're kissing here. So they have to be straight lines crossing though. So we have two pairs of vertical angles in the first one. On the second diagram here though, this is bad. These are not vertical angles. These angles right here, this one and this one, the problem is the lines are not straight. This line right here is not straight, so these are not vertical angles. They have to be when straight lines cross. Okay, so let's take a look at a problem here, or first see what's true about them. If we fill out enough of these patterns here, and we did a few in class, we get to see that vertical angles are equal. So as we go around and fill in the angles here, this angle right here, because these two form a line, add to 180. So 180 minus 54 is 126. So that one would have to be 126 degrees. And the way I got that was 180 minus 54. Okay, so if I found this angle over here, which is vertical with the other 54 degrees, I see that if I do 180 minus 126, I get 54 again. So I did 180 minus the angle next to it, and I got 54. So we see that these opposite ones end up being congruent. Then if I fill in the last missing angle, do 180 minus 54, I'm back with 126 again. So if you do it, like I said, if you do enough of these, you realize the opposite ones always end up being equal. Their measures are equal. So the same thing here. This angle right here, if I do 180 minus 88 degrees, I find that this one is 92. If I do 180 minus 92, I'm back to 88. And these are vertical angles. They're straight lines are crossing, and they're the opposite angles. And if I do 180 minus 88, I got 92 again. So we see that the opposite ones are equal in measure, which means the angles are congruent. Okay, so of course, we love doing algebra, and this always ends up being an algebra problem. So we see we have two vertical angles here, this one and this one. The other two are vertical too, but the problem's focused around the ones with the expressions. So we got to remember the geometry fact. Vertical angles are congruent. So in this case, we're going to set these equal to each other. So it seems like in a lot of problems, we're either adding the angles to 180 or setting them equal to each other. So we just got to remember the geometry here. These two are vertical angles, so their measures have to be equal. Okay, we have x on both sides. And solving the actual equation we get is not going to be a problem. So we get x minus 14 equals 26. And if I add 14 on both sides, I get x equals 40. Okay, and I could go back and actually plug in if I wanted the actual angles. 2 times 40 is 80, plus 26 is 106. 3 times 40 is 120, minus 14 is 106. These worked out to be the same. They were supposed to be the same. They're supposed to be equal there. All right, two more quick examples. This first one, if I look, I got to think about what's the relationship. So that's the geometry. The first step is geometry. These are vertical angles, so they have to be congruent. So I'm going to set them equal to each other. 5x plus 7 equals 3x plus 23. If I get that step right, it's all going to be good. So, because after that, this is the easy algebra. So we get 2x plus 7 equals 23. If I subtract 7 from both sides, I get 2x equals 16. If I divide by 2, I get x equals 8. That's the value that makes these angles equal. All right, we have to be careful though. So we have to look at this situation. These two angles that are labeled are not vertical angles. They form a straight angle. They're a linear pair. They form a straight line. So this is the straight angle right here. So they're not equal in this case. When they form a linear pair, they have to add to 180. So that's the tricky part here. It's deciding what's true about the given angles. Are they congruent? And setting, do we set them equal, or do we add them and set them equal to 180? So these are a linear pair, form a line, they add that 180. So here we go. I get 4x plus 40 equals 180. And if I subtract 40, I get 4x equals 140. Or x equals, let me see what we get here. 140 divided by 4, it would be 35, I believe. I was looking for my calculator, but we got this, 35. All right, now, one last thing. On being pre-AP students, like you are, you're going to be responsible for proving why vertical angles are congruent and kind of understanding how we can show this is true always. And we got our buddy here, Euclid, who introduced proofs into geometry and made geometry very systematic. He'll be proud of us for doing this. All right, so we'll get a little bit more, we'll have more details about this soon. I just want to start. And how do we do a proof, or at least give an explanation? So we want to show that angle 1 and angle 3, their measures are equal. That's what this says. The measure of angle 1 equals the measure of angle 3. So I'm going to start with the observation that the measure of angle 1 plus the measure of angle 2 equals, guess what? They form a linear pair, so they have to equal 180. We'll write the reasons later. So I said it verbally. They equal 180 because they form a linear pair. So 2 and 3 form a linear pair. So I'm going to write the measure of angle 2 plus the measure of angle 3 equals 180. Now, since both of these equal 180, they equal each other. Measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 2 plus the measure of angle 3. Since both sides are equal to 180, they got to be equal to each other. The left side equals 180, the right side equals 180, so they equal each other. So now I'm going to do one smooth move here. I'm going to subtract the measure of angle 2 from both sides, and I'm going to have what I want. When I subtract the measure of angle 2 from both sides, I get the measure of angle 1 equals the measure of angle 3. So I've kind of shown it in general that's true. And there was nothing special about this diagram. It represented every situation we come across with vertical angles. And so I demonstrated that these opposite ones truly have to be equal. Now, we're going to talk more about proofs very soon. And actually this one will be no problem for you guys after we do a few of them. I just wanted to introduce it now. Okay. Time for the journal assignment. I told you it's going to be a short video. We're under the 10-minute mark, which is good. So copy the figure below, find the measures of A, B, and C there, find out what they're equal to. And in the second figure, copy this also, write an equation to solve for x and solve it. Okay, see you in class.